Hey guys, here's a basic dynamics problem where we deal with friction, and in particular the coefficient of friction. This is the example problem we did in class. We have a box that accelerates across a carpeted floor. They give you the acceleration, and say that it accelerates due to a pulled horizontal applied force. So I'm going to draw a picture. We're going to start with our free body diagram. That's always a good place to start. We're on level ground. It doesn't say indicate anything otherwise. They give you the mass. So I'm just going to write in here that that's the mass of the object. Uh, every object is going to have a force of gravity acting on it. In this case, since it's on flat ground, uh, there's no other vertical forces. We can draw in the normal force, and we're going to draw it as the same length. Sum of the forces vertically have to equal 0 because it's not accelerating vertically. This acceleration they give you is an acceleration that is to the right, and it's equal to 2 meters per second squared. And since the right would be the x direction and up would be the y, that would be an acceleration in the x direction. And so the acceleration in the y would be 0, which is why we know the normal force will equal the force of gravity. We're also told that there is an applied force to the right, Fa, and they tell us that value is 40 newtons. Since we're on a surface and we're moving along a surface, we also must have some friction. Now, when I draw the friction force, I'm going to draw that arrow as less than the arrow that's applied. So that friction is pulling to the left. That's opposing the direction of motion, which will be to the right. And again, the smaller arrow just indicates that there must be a net force to the right because we know it's accelerating. So in this case, let's do a couple calculations. Let's figure out what Fg is. Fg is always equal to the mass times the acceleration due to gravity. So anytime we're given the mass, we can always find Fg, and that's going to be 12 kilograms times negative 9.8 meters per second squared. When I pull out my calculator, 12 times 9.8 gives me 117.6. So the value is negative 117.6 newtons. So if I was going to use that in an equation, I would make sure it's negative because it's downward. However, in my picture, since I've drawn the arrow downward, I can just say it's 117.6 newtons. And because it's not accelerating vertically, the only other force is the normal force, and so I know it also has to be 117.6 newtons. All right, and that's going to be helpful later because what they're asking for is that coefficient of friction, which is a function of that normal force. So the next step is let's figure out what friction is. And we know that Newton's second law says that the sum of all forces equals the mass times the acceleration. In this case, we care about the forces in the x direction because that's the direction of friction that's unknown. It's equal to acceleration in the x. And the forces that are adding together are friction and the applied force. We're going to add them up. The sum of those forces is equal to the mass times the acceleration in the x. And let's plug in what we know. Friction plus the applied force, which is positive 40 newtons, it's to the right, equals the mass, 12 kilograms, times the acceleration, which is positive 2 meters per second squared. And so I have force of friction plus force equals 24. And so we get the force of friction to be negative 16 newtons, which makes sense. It's to the left, which is how we draw it on our picture, and it's also less in magnitude. It's a shorter arrow. It's only 16 instead of 40. Now, the last step is to answer the question. We're looking for the coefficient of friction. In this case, it's a moving object, so technically it would be a kinetic coefficient, but they don't really specify, so I'm just going to put mu right now. And that's always equal to the force of friction over the normal force. It's important to remember that we really only care about the length of these arrows when we're getting mu, which is why I like to put the absolute value over there. That way you don't end up with a negative number. In this case, the force of friction is negative 16, and the normal force is 117.6. Again, I just want a positive value. So I'm going to take 16 divided by 117.6. I get 0.136. as my coefficient of friction. And again, this would be a kinetic coefficient because it's a moving object. So we could put UK under there if we want to be specific, but they didn't indicate that in the problem. I hope this is helpful. I'll pause here so you can see the work, but there's our coefficient of friction. It's pretty small friction here on this carpet.